In the 1970s, a scientist named Jack Sepkoski embarked on the most ambitious fossil hunt ever. But instead of digging in the dirt, he dug through dusty piles of academic research and scraped together a record of all the ocean-dwelling creatures known to science. It was tedious work, but the data it yielded gave rise to perhaps the most famous chart in paleontology, a tally of marine life over time that revealed 5 catastrophic global biodiversity crashes in Earth's past. Those crashes, known as the Big Five mass extinctions, are commonly believed to have been the biggest die-offs in Earth's history, both in and out of the oceans. They include that time 66 million years ago when a huge meteorite took out the non-avian dinosaurs, as well as the even more apocalyptic extinction at the end of the Permian period, which wiped out more than 90% of Earth's species. But the Big Five weren't the only big mass extinctions, and they might not have even been the biggest. Take the Great Oxygenation Event of 2.3 billion years ago. Evidence from ancient rocks tells us that levels of atmospheric oxygen spiked around this time, poisoning the oxygen-hating microbes that had dominated Earth for well over a billion years. And yet, we can't really say how that extinction compares to the Big Five, because its victims were microscopic and left virtually no signature in the fossil record. In fact, the fossil record only captures a tiny fraction of the life that has ever existed on our planet, but it also captures a different fraction from one period to the next. In general, the record gets less and less complete the further back in time you go, but that trend is complicated by several other factors. For one, we have a lot more fossils from swampy places and periods of the past, not necessarily because those periods were more diverse, but because the calm, muddy conditions were perfect for preservation. We also have a lot more rock from some periods of time than others, and in general, the more rock we have, the more fossils we find, and the more abundant life appears to have been. In other words, the fossil record is inconsistent, so we can't just tally the number of species and take the results at face value, as Sepkoski's Big Five chart did. But paleontologists have used some clever statistics to adjust for those inconsistencies, and the latest diversity curve makes it look like there have been 8 major mass extinctions rather than 5. But you could also count 11, or just narrow the list to the 3 most massive. In short, it's pretty arbitrary. What isn't arbitrary is that some mass extinctions alter the evolutionary tree of life far more radically than others. For example, the first of the Big Five pruned away more than 80% of the species on Earth, but it left all the big branches of the tree intact, so life went on more or less as it had before. Other mass extinctions, even some smaller ones like the one 66 million years ago, trimmed the evolutionary tree far less evenly, decimating some previously thriving branches and preparing others for world domination. Hey, this is Emily. On behalf of everyone here at Minute Earth, I just want to send out a big thanks to Audible for supporting our channel. Audible.com is the leading provider of audiobooks across all types of literature, including fiction, nonfiction, and periodicals. Audible is offering a free 30-day trial for Minute Earthlings. Just go to audible.com/MinuteEarth to sign up. And if you don't know what you want to listen to first, I'd recommend The Poisoner's Handbook by Deborah Blum. It's a fascinating history of famous poisons and poisoners, and the first forensic scientists working to detect and track them. Again, that's audible.com/MinuteEarth for your free 30-day trial. Thanks, Audible!